Good day to each and everyone. Fieldwork exercise number 2, entitled Taping over smooth or level and unlevel ground. Introduction. The common method in measuring the distance is by direct measurement with a tape. The distance measured with a steel tape is much more precise than the distance obtained by pacing. The precision obtained depends upon the degree of refinement with which the measurements are taken. Ordinarily, taping over flat, smooth ground with a steel tape or chain divided in thousandths of a meter provides a precision of 1 in 3,000 to 1 in 5,000. When the ground is fairly smooth and the ground cover vegetation is light and low, the effort required to measure the distance between 2 points or to set a point ahead of some required distance is very minimal. The ground is not too rough and hilly and in general considered as gently rolling. The taping procedure required would be slightly more difficult than the required for taping on a flat ground. In this fieldwork report, the surveyor will learn techniques and principles as well as some consideration to be made when taping a level ground and uneven ground. Objectives. First is to develop the skills of taping the distance on a level ground where the tape is fully supported by the ground. Next is to acquire the skills of taping the distance on uneven ground where the tape is only supported at the ends. Instruments and accessories. The instruments and accessories needed are range poles, 50-meter measuring tape, and marker. It's either chalk or marking pins. Procedure. Taping over smooth or level ground. The professor assigns the accessible and unobstructed course to be measured by the surveyor on a level ground. Mark the endpoints by a chalk if it is on pavement or by a marking pin if it is on soft ground, and designate it as endpoints A and B. A range pole man holds the pole vertically and steadily during the entire taping procedure at B to keep the complete taping process aligned and straightened. The tape is stretched out on the ground on the straight path along A to B where the zero end is held ahead. The rear tape man is responsible for giving the signal to the front tape man if his path is straight, while the front tape man is responsible to pull the tape out once the tape is aligned already. The front tape man gets a pin and sticks it vertically in the ground exactly opposite the 0-meter mark of the tape. Rear tape man holds one pin and the rest of the pins are held by the front tape man. Both the front and the rear tape man lift simultaneously the tape and move forward along the line AB to measure the next tape length. By now, the rear tape man holds one marking pin which signifies one tape length.
The procedure 4 to 6 is repeated to complete the next tape length measurement. Make sure that the rear tape man pulls the pin before lifting the tape to move on to the next tape length. The rear tape man holds two marking pins to connote two tape lengths have been measured. Repeat the same process until all the pins being held by the front tape man have been used up. which signifies one tally or the 10 tape lengths. After a tally has been accomplished, the rear tape man returns all the 10 pins to the front tape man to proceed in measuring the length of the horse. Note: one round is when all the 10 pins are now being held by the rear tape man. Repeat the same procedure if more than one tally is needed. Upon reaching point B, the partial length must be measured accurately up to the centimeters by the rear tape man, while the front tape man is holding the zero mark at B and both of them are holding the tape top. The number of small pebbles in the rear tape man's pocket now indicates the number of tallies made, and the number of pins in his possession indicates the number of additional tape lengths. To compute for the total distance, get the total number of full tape lengths and then add the partial tape lengths to the product of the length of one full tape length and the total number of full tape lengths. To compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. To get the relative precision, determine the probable error of the mean, then divide by mean distance, and reduce the numerator to unity to determine the relative precision.
Taping over uneven ground.
The same course is measured, but this time the tape will be unsupported by the ground and must be held an eye level distance above the ground. Both the rear and the front tape man hold a plumb line over the center of the hub. The front tape man must hold this plumb line an arm length away from his body for the rear tape man to clearly see if it is aligned in the range pole at B. Once the rear tape man approves the alignment, the front tape man holding the zero mark pulls the tape taut and drops plumb bob on the ground. This will mark the ground with a dent to guide the front tape man to where he must place his marking pins. This is to be done continuously until point P is reached. Note that the partial length must also be measured as in procedure A. The course is measured back and forth to complete the number of trials required by the professor. Tabulate the data in Table 2.2, taping over uneven ground. To compute for the total distance, get the total number of full tape lengths and then add the partial tape length to the product of the length of one full tape length and total number of full tape lengths. To compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. And lastly, to get the relative precision, determine the probable error of the mean, then divide by the mean distance, and reduce the numerator to unity to determine the relative precision. And that's all for our group activity, the surveying fieldwork number 2.